Okay, so we've been looking at how man-made changes in our environment can affect wildlife. Now, I'll discuss a particular example. Let's take a look at mercury. Mercury's one of the 120 or so elements that make up all matter, and it has the symbol Hg. It's a shiny, silvery substance. You may have seen it in old-fashioned thermometers, but it's not used much for domestic purposes now because it's highly toxic. But the problem is that the amount of mercury in the environment's increasing. The main reason for this is the power plants used to produce electricity. The main source of energy that most of them use is still coal, and when it's burned, it releases mercury into the atmosphere. Some of this gets deposited into lakes and rivers, and if it's ingested by a fish, it's not excreted. It stays in the fish's body, and it enters the food chain. So, it's been known for some time that birds which eat fish may be affected. But what wasn't known until quite recently is that those that eat insects can also be affected. So, a woman called Claire Varian Ramos is doing some research on how this is affecting birds. And rather than looking at how many birds are actually killed by mercury poisoning, she's looking for more subtle sub-effects. And these may be to do with the behaviour of the birds, or with the effect of mercury on the way their brain works, so whether it leads to problems with memory, for example. And she's particularly focusing on the effects of mercury on birds' song. Now, the process of song learning happens at a particular stage in the bird's development, and what you may not know is that a young bird seems to acquire this skill by listening to the songs produced by its father, rather than by any other bird. And Varian Ramos has already found in her research that if young male birds are exposed to mercury, if they eat food contaminated with mercury, then the songs they produce aren't as complex as those produced by other birds. So, quite low-level exposure to mercury is likely to have an impact on male birds in a natural situation because it can mean that they're less attractive to female birds, and so it can affect their chances of reproduction. Now, the way she's carrying out this research is worth thinking about. She's using a mixture of studies, using birds kept in laboratories and studies carried out outdoors in the wild. The lab-based studies have the advantage that you don't get all the variables you would in a natural setting. So, the experimenter has a much higher level of control, and that means they can be more confident about their results in some ways. And of course, they don't have to worry about going out and finding the birds in order to observe them. So, what are the implications here for humans? Well, because many birds are migratory, they may be transporting mercury far from contaminated sites. For example, it's been found that ducks who'd been feeding at a contaminated site were later shot by hunters over 1,000 kilometres away, and presumably eaten. But these birds likely had mercury levels high enough to warrant concern for human consumption. In addition, going back to song learning by birds, we saw that this may be affected by mercury contamination. Well, we also know that in humans, mercury causes developmental delays in the acquisition of language, and in fact this process is very similar in the brain regions it involves, and even the genes that are involved. But mercury contamination has other important implications for humans as well. It's now known that an unborn child can be affected if the food eaten by its mother contains high levels of mercury, and these effects can be quite substantial. In the end, it comes down to whether more value is placed on human economic well-being or environmental well-being. It's true there are new regulations for mercury emissions from power plants, but these will need billions of dollars to implement and increase costs for everyone. Some argue that's too much to pay to protect wildlife, but as we've seen, the issues go beyond that, and I think it's an issue we need to consider very carefully.
In public discussion of business, we take certain values for granted. Today, I'm going to talk about 4 of them: collaboration, hard work, creativity, and excellence. Most people would say they're all good things. I'm going to suggest that's an over-simple view. The trouble with these values is that they're theoretical concepts, removed from the reality of day-to-day business. Pursue values by all means, but be prepared for what may happen as a result. They can actually cause damage, which is not at all the intention. Business leaders generally try to do the right thing, but all too often the right thing backfires if those leaders adopt values without understanding and managing the side effects that arise. The values can easily get in the way of what's actually intended. Okay, so the first value I'm going to discuss is collaboration. Let me give you an example. On a management training course I once attended, we were put into groups and had to construct a bridge across a stream using building blocks that we were given. The rule was that everyone in the team had to move at least one building block during the construction. This was intended to encourage teamwork. But it was really a job best done by one person. The other teams tried to collaborate on building the structure and descended into confusion, with everyone getting in each other's way. Our team leader solved the challenge brilliantly. She simply asked everyone in the team to move a piece a few centimetres to comply with the rule, and then let the person in the team with an aptitude for puzzles like this build it alone. We finished before any other team. My point is that the task wasn't really suited to team working, so why make it one? Teamwork can also lead to inconsistency, a common cause of poor sales. In the case of a smartphone that a certain company launched, one director wanted to target the business market, and another demanded it was aimed at consumers. The company wanted both directors to be involved, so gave the product a consumer-friendly name, but marketed it to companies. The result was that it met the needs of neither group. It would have been better to let one director or the other have his way, not both. Now, industriousness, or hard work. It's easy to mock people who say they work hard. After all, a hamster running around in a wheel is working hard and getting nowhere. Of course, hard work is valuable, but only when properly targeted. Otherwise, it wastes the resources that companies value most, time and energy, and that's bad for the organisation. There's a management model that groups people according to 4 criteria: clever, hard-working, stupid, and lazy. Here, lazy means having a rational determination not to carry out unnecessary tasks. It doesn't mean trying to avoid work altogether. Most people display 2 of these characteristics, and the most valuable people are those who are both clever and lazy. They possess intellectual clarity and they don't rush into making decisions. They come up with solutions to save the time and energy spent by the stupid and hard-working group. Instead of throwing more man-hours at a problem, the clever and lazy group looks for a more effective solution. Next, we come to creativity. This often works well. Creating an attention-grabbing TV commercial, for example, might lead to increased sales. But it isn't always a good thing. Some advertising campaigns are remembered for their creativity without having any effect on sales. This happened a few years ago with the launch of a chocolate bar. Subsequent research showed that plenty of consumers remembered the adverts, but had no idea what was being advertised. The trouble is that the creator derives pleasure from coming up with the idea and wrongly assumes the audience for the campaign will share that feeling. A company that brings out thousands of new products may seem more creative than a company that only has a few, but it may be too creative and make smaller profits. Creativity needs to be targeted to solve a problem that the company has identified. Just coming up with more and more novel products isn't necessarily a good thing. And finally, excellence. We all know companies that claim they strive for excellence, But it takes a long time to achieve excellence. In business, being first with a product is more profitable than having the best product. A major study of company performance compared pioneers, that is, companies bringing out the first version of a particular product, with followers, the companies that copied and improved on that product. The study found that the pioneers commanded an average market share of 29%, while the followers achieved less than half that, only 13%, even though their product might have been better. Insisting on excellence in everything we do is time-consuming, wastes energy, and leads to losing out on opportunities. Sometimes second-rate work is more worthwhile than excellence. Make sure it's excellent sounds like a good approach to business, but the just get started approach is likely to be more successful.
An interesting aspect of fireworks is that their history tells us a lot about the changing roles of scientists and technicians in Europe. Fireworks were introduced from China in the 13th century. Up to the 16th century, they were generally used for military purposes, with rockets and fire tubes being thrown at the enemy. But they were also sometimes a feature of plays and festivals, where their chief purpose was related to religion. By the 17th century, the rulers of Europe had started using fireworks as a way of marking royal occasions. Technicians were employed to stage spectacular shows which displayed aspects of nature, with representations of the sun, snow and rain. These shows were designed for the enjoyment of the nobility and to impress ordinary people. But fireworks also aroused the interest of scientists, who started to think of new uses for them. After seeing one firework display where a model of a dragon was propelled along a rope by rockets, scientists thought that in a similar way humans might be able to achieve flight, a dream of many scientists at the time. Other scientists, such as the chemist Robert Boyle, noticed how in displays one firework might actually light another, and it occurred to him that fireworks might provide an effective way of demonstrating how stars were formed. Scientists at the time often depended on the royal courts for patronage, but there was considerable variation in the relationships between the courts and scientists in different countries. This was reflected in attitudes towards fireworks and the purposes for which they were used. In London, in the middle of the 17th century, there was general distrust of fireworks among scientists. However, later in the century, scientists and technicians started to look at the practical purposes for which fireworks might be employed, such as using rockets to help sailors establish their position at sea. It was a different story in Russia, where the St. Petersburg Academy of Science played a key role in creating fireworks displays for the court. Here, those in power regarded fireworks as being an important element in the education of the masses, and the displays often included a scientific message. Members of the Academy hoped that this might encourage the royal family to keep the Academy open, at a time when many in the government were considering closing it. In Paris, the situation was different again. The Paris Academy of Sciences played no role in staging fireworks displays. Instead, the task fell to members of the Royal Academy of Painting and Sculpture. As in Russia, the work of the technicians who created the fireworks was given little attention. Instead, the fireworks and the spectacle they created were all designed to encourage the public to believe in the supreme authority of the king. However, science was also enormously popular among the French nobility, and fashionable society flocked to demonstrations such as Nicolas Lemery's display representing an erupting volcano. The purpose of scientists was basically to offer entertainment to fashionable society, and academicians delighted in amazing audiences with demonstrations of the universal laws of nature. In the course of the 18th century, the circulation of skills and technical exchange led to further developments. Fireworks specialists from Italy began to travel around Europe, staging displays for many of the European courts. the architect and stage designer Giovanni Servandoni composed grand displays in Paris, featuring colourfully painted temples and triumphal arches. A fireworks display staged by Servandoni would be structured in the same way as an opera, and was even divided into separate acts. Italian fireworks specialists were also invited to perform in London, St. Petersburg, and Moscow. As these specialists circulated around Europe, they sought to exploit the appeal of fireworks for a wider audience, including the growing middle classes. As in the previous century, fireworks provided resources for demonstrating scientific laws and theories, as well as new discoveries, and displays now showed a fascinated public the curious phenomenon of electricity. By the mid-18th century, fireworks were being sold for private consumption. So the history of fireworks shows us the diverse relationships which existed between scientists, technicians, and the rest of society.
Good morning. Today, we're thinking about the way that technology is influencing our social structures and the way we interact with one another. Humans, as we know, have always lived in groups. Without this arrangement, our species would have died out long ago. But now, the way we see and define our group is changing. I'd like to start by mentioning the research of American sociologist Mark Granovetter in 1973. It was Granovetter who first coined the term weak ties, which he used to refer to people's loose acquaintances. In other words, friends of friends. His research showed that weak ties had a significant effect on the behavior and choices of populations, and this influence was something highly important in the fields of information science and politics, and as you can imagine, marketing also. So, these friends of friends, people we might spend time with at social or work gatherings, might not be like us, but they can still have a positive influence because we share the same sort of interests. That's enough to make a connection, and this connection can turn out to be more beneficial than we might suspect. An example of this, an example of how the connection can influence us, is when our weak ties get in touch and pass on details about jobs they think might be suitable for us. Well, since Granovetter first came up with this theory, his work has been cited in over 19,000 papers. Some of these studies have looked at how weak tie networks are useful to us in other ways, and one thing that seems to improve as a result of weak tie influence is our health. Today, our number of weak tie acquaintances has exploded due to the internet, to the phenomenon of online social networking. This is still a relatively new way of communication, something that has a huge amount of potential. But also, as with any invention, it brings with it a new set of problems. Let's start with the benefits. Without question, online social networking allows us to pass on the latest news, to be up to date with local and global events, and for many, this information comes from sources more trustworthy than local media. So this is one clear point in favor of online social networking. I know that it's also being used by students as a means of increasing their chances of success in the way that lecture notes can be shared and ideas discussed. I think, personally speaking, that we need some further research before we can definitively say whether it helps or not. There's also been a great increase in the number of networking sites devoted to sharing advice on health issues, but there are as yet no studies to prove the reliability of that advice. Now, what we do have clear evidence for is that people are developing friendships and professional networks in a way that wasn't possible before. The process is faster. I'm not talking about quality here, but simply that they exist. And it's debatable whether the number of online friends that you have increases your level of self-confidence. That's perhaps an area of research some of you might be interested in following up. Turning to the problems, there are any number of articles connecting online activity to falling levels of physical fitness. But it's too easy to blame the internet for our social problems. The poor grades of school children are also frequently linked to the time spent on social networking sites. But it would be naive to believe there are no other contributing factors. One real concern, however, is the increase in the amount of fraud, where, for example, people are using the personal data of others, which they've put online, for criminal purposes. This kind of activity seems likely to continue. And then, certainly for employers, online social networking sites have provided a great time-wasting opportunity, reducing productivity like never before, and I doubt they can put a stop to this habit, no matter what restrictions are in place. We'll come back to these issues in a minute, but I'd like to say something about the theories of Robin Dunbar, an anthropologist at Oxford University. Dunbar has found that the human brain has evolved in a way that means we can only give real attention to a particular number of people. 150, apparently. So, for example, if the number of friends on your online network is greater than that, according to Dunbar, this would imply the relationships are only superficial. Dunbar is not against online relationships, but he maintains that face-to-face interaction is essential for the initial creation of true friendship and connections. He's concerned that for young people, if their only experience of forming relationships is online, this doesn't allow them to form the ability or acquire the strategies for maintaining relationships. For example, in situations where negotiation or diplomacy is required, or where it's essential for...
Hello everyone and welcome. As part of this series of lectures on the development of early humans, today we are looking at rock art, the paintings and drawings produced by prehistoric peoples as they spread across the continents. If you've been lucky enough to look at a piece of rock art close up, you will know it's an experience that makes you wonder about the passage of time and our own history. But rock art also has a practical value for researchers, and let's start by considering why that is. Firstly, it provides vital information about the way that people evolved, information not always easily obtainable from excavated artifacts alone. Secondly, rock art tells us about migration, where people came from and where perhaps they went next. Rock art is found all over the world, and this in itself is not surprising. But what is rather amazing, you might think, is how similar some images are, whether you're looking at a rock face in South Africa or standing inside a cave in Spain. Let me give you an example. When our ancestors drew humans, they would often draw them as stick figures. But if they drew a face, then the eyes were almost always very prominent, very open and wide. And of course, animals are very common in rock art. But one animal which is very interesting to researchers is the lizard, because whenever you see a prehistoric painting of one, it's depicted either in profile or looking down on it from above. And these drawings are produced by people of totally different cultural backgrounds. Amazing. But how can this be the case, that similar artistic styles exist in such distant locations? In the past, archaeologists believed that trade must have brought people together, and that it gave them the opportunity to observe each other's culture, including art styles. But this didn't prove to be the case. Recently, researchers have come up with a new theory. They believe that the brains of our ancestors evolved to notice certain images before others, and this was important, actually essential, because in an environment full of constant danger, it was necessary for survival. So the need to quickly recognize things that could be helpful or harmful could have had a great influence on rock art, and explain why some images are more common across cultures than others. Later on, there would have been other reasons why communities produced art, certainly for spiritual and social purposes, and no doubt for political ones too, as different tribes looked for allies and struggled against their enemies. Well, as I said before, you can find rock art all over the world, but I'd like to focus now on the rock art of the Aboriginal people of Australia. The images that survive in this part of the world span at least 20,000 years. In fact, the Aborigines were still practicing this art form in the late 18th century when the Europeans began to arrive, and certain images point to the contact between them. For example, the Aborigines began to draw ships which they would have seen along the coast. It's hard for us to imagine what they must have thought when these first began to appear. Another image that is evidence of European arrival is that of horses, an animal that would have been very alien to the Australian landscape. It isn't actually known how many sites there are across Australia where rock art can be found, but unfortunately we do know that much of the art is being lost to us. Erosion, of course, is one of the key reasons for its destruction, but human activity is also increasingly responsible. Since the 1960s, industry alone has destroyed around an estimated 10,000 pieces of art. At this rate, in 50 years, half of all Australian rock art could have disappeared for good. Vandalism is sadly another factor, and although most people, I believe, would wish to preserve this art, I'm afraid that tourism is another reason why the art is disappearing.
Today I'm going to talk about the graphical symbol. A graphic symbol is a written symbol that is used to represent speech, such as those used in the Greek alphabet. The term graphic symbol encompasses anything from the logographs used in Egyptian hieroglyphic writing to ancient Chinese pictograms. Early symbols were based on pictographs and ideograms before they were developed into logographic writing systems. These systems are still in use in some non-literate cultures in Africa, the Americas, and Oceania. Indeed, elements of pictography are still found in modern Chinese characters, and it is often an interesting exercise to trace the origins of some Chinese characters. Pictographs remain in common commercial use today as signs, instructions, or statistical diagrams. Road signs and public toilet signs, and even flat pack assembly instructions utilizing pictures, are considered pictographic. Ancient graphic writing systems provide researchers with a wealth of knowledge about past civilizations. In 1799, one of the most important historical discoveries was made by accident when members of Napoleon's expedition to Egypt found a stone in Rosetta that exhibited 3 different scripts. The stone, now known as the Rosetta Stone, was studied in significant depth by scholars and was first deciphered by Frenchman Jean-François Champollion in 1822. He was able to correctly determine the phonetic values of the symbols, and later research has confirmed his findings. In many of these symbols, lines are used to portray a multitude of meanings, and knowledge and understanding of these lines holds the key to comprehension of graphic writing systems. A key moment in the history of communication was the invention of the camera obscura, or camera. Although the concept can be traced back to the 5th century BC Chinese philosopher Mo Ti, the first photographic image was ultimately created in 1826 by Joseph Nicephore Nicephh. Photography, as it was later known, enables researchers to piece together and better understand history. Today, photography forms a huge part of everyday life, and most publications contain a vast number of photographs. Photography is used in advertising, and is now becoming a way to increase awareness of existing world issues. For example, animal welfare charities are increasingly using photography to advertise animals that are at high risk of endangerment. Charity workers are sometimes flown to far-flung locations to document the suffering endured by high-risk animals in an attempt to raise human awareness of their consumption activities and how they impact others. One recent high-profile campaign was undertaken by attaching a camera to the foot of a bird in order to obtain photographs of the animals in their natural habitats and understand how often they come into contact with human waste. A soon-to-be-released documentary about the suffering of animals on Midway Island shows the full extent to which human consumption is harming animals thousands of miles away from us. As photography continues to progress, with the use of drones now becoming somewhat commonplace, we should expect more and more objects to be included in the future, expanding the horizon of photography ever further. Indeed, the downward pressure on traditional media prices means that media companies are being forced to get creative on how to make a profit. Many have found that the answer to this lies in advertising, and companies are now willing to devote a large portion of their budgets to advertising in newspapers. By the same token, marketing has become an essential part of a company's business model, often meaning the success or failure of a company. As a result, much time and money has been pumped into the development of effective branding, with attractive packaging playing a large role in this. However, many governments are now seen to be cracking down on marketing and packaging in an attempt to protect consumers from being misled. In particular, tobacco companies are now subject to ever-increasing regulation. For example, in the United Kingdom, legislation is soon to pass preventing any form of branding or differentiation on cigarette packaging in efforts to curb the harmful effects of smoking. Finally, one must not forget the fundamental role that graphic writing systems have had to play in mathematics. Graphs, icons, and diagrams often form the very basis of these branches of academia. Indeed, one needs to look no further than chemistry's periodic table to see a perfect example of graphic writing systems in use today.
Today, I'm going to be talking about the history of the measurement of time, something we all take for granted now. These days, we're able to measure time extremely accurately, and there's global agreement on what the time is anywhere in the world. But of course, this has not always been the case. So, when and how did it all begin? Well, we can tell that prehistoric people from 30,000 years ago were aware of the changes of the moon as time went by. But 25,000 years passed before humans began to actually track time. There is credible evidence for this from around 5,000 years ago, and they did this by observing not just the movement of the sun, moon, and stars, but by measuring where these were in relation to the Earth, and in particular, where these were in relation to the horizon. This was known as horizon tracking. For example, they noted the position on the horizon of the sun at sunrise and sunset, and how these positions changed throughout the year. From this, they were able to predict when the longest and the shortest days of the year were. Initially, this measurement was quite inaccurate and relied on suitable natural markers being on the horizon, such as hilltops, trees, etc. But measurement became more accurate and detailed when certain communities built markers specifically to view how the positions of the sun and moon related to them. One of the best remaining examples of these is Stonehenge in England, which consists of a number of very large stones arranged in a circle. Okay, so let's have a look at the first clocks. It wasn't until around 1400 BC that the first primitive clocks were used to measure length of time. These were water clocks, and time was measured by filling a bucket with water which had a small hole in the bottom of it. As the water dripped out, the water level went down, marking the passage of time. Early civilizations also used the sun to measure time. Sundials were used to cast a shadow from the sun onto a horizontal surface marked with lines, indicating the hours of the day. As the sun moved across the sky, the direction of the shadow moved across the dial, and the time could be read. Early time measurement in China and Japan also involved the burning of incense sticks. The longer the stick, the longer it burnt, and so standard lengths were used to measure lengths of time. Sometimes a stick with a different smell was burnt at a certain point in the day, and workers would know when to move on to the next task because of the change in incense. Let's now look at mechanical clocks. The first evidence of these is in the late 13th century in northern Europe. They were made of iron, rather large and heavy, and the wheels of the clock were driven by a weight, which slowly descended. Initially, mechanical clocks didn't have a clock face and just struck a bell every hour. They were also only accurate to the nearest quarter of an hour, but it didn't matter if the time wasn't quite right, because there was only one clock in each community. However, when people travelled to other communities, they discovered the time there was different. This first became a real problem with the introduction of the railways in the 1840s. Up until then, sundials had been the most accurate way of telling the time, But these were dependent on shadows made by the sun, and this was too inaccurate for producing timetables. This meant that there was a need for a nationally agreed time system. And in 1847, the time at Greenwich in London was taken to be the point on which the national time was based. There was inevitably a lot of resistance to this in the middle decades of the 19th century. People in other places, like Bristol, for example, wanted their own time and didn't want to be dictated to by London. An even bigger problem came a few years later with the need for a globally recognized time system. International shipping at that time used maps on which Greenwich was the main reference point. As zero longitude passed through Greenwich, it was decided at a conference in Washington that all longitude would be calculated east and west from there. So then it made sense to use Greenwich to also measure time for the whole world, starting at the observatory at midnight. People could therefore be confident that when it was 8 a.m. in California, it was 5 p.m. in Paris every day.
How many fish are in the sea? It's a hot topic for many scientists. Today we have invited a famous scientist who spent 10 years studying marine life to give us an introduction of the latest survey called the Census of Marine Life. Let's welcome Alok Jha.
Thanks, Ella. The Census of Marine Life has been the biggest and most comprehensive attempt ever to answer that question. How many fish are in the world's oceans? The Census of Marine Life, which hopes to indicate a baseline of marine life, estimates that there are more than 230,000 species in the sea. The study covers from coast to the open ocean, from the shallows to the deeps, from little things like microbes to large things such as fish and whales. A team of over 360 scientists from all over the world have spent the past 10 years surveying 25 regions, from the Antarctic through to the temperate and tropical seas to the Arctic, to count the different types of plants and animals. The findings indicate that crustaceans such as lobsters, crabs, krill, and barnacles account for a fifth of the number of species in the world's oceans, and half of the world's marine species is mollusk, squid and octopus, and fish, including sharks. The charismatic species usually used in propagating environmental protection, for example whales, sea lions, turtles, and seabirds, account for less than 2% of the species in the world's oceans. The study has also focused on major fields of concern for conservationists. In every region, they got the same experience of a major collapse of what were usually very abundant fish stocks or crabs or crustaceans that are now only 5 to 10% of what they used to be. The main reasons include overfishing, degraded habitats, and pollution. But more problems are presented. Rising water temperatures and acidification brought by climate change and the growth in areas of the ocean that are low in oxygen and therefore unable to support marine life. The Census of Marine Life shows that enclosed seas, such as the Mediterranean Sea, the Gulf of Mexico, China's shells, the Baltic, and the Caribbean, have the most threatened biodiversity. The pollutions in enclosed seas are mainly from chemicals or garbage that people throw into it. Dense coastal populations of humans also tend to be packed along enclosed seas, meaning rising contaminations and extraction of more biodiversity from the water. The Mediterranean Sea, which contains around 17,000 identified species, has been a region with high threat. Scientists in our team studying the Mediterranean identified problems related to increased litter from shipping and munitions across the sea, as well as bombs discharged during the Kosovo War. The Mediterranean also has to face problems with invasive species, displacing the creatures that already live there. The Census of Marine Life shows that the Mediterranean Sea has the most alien species, more than 600, among all the 25 regions that have been surveyed. It looks like the region with coral reefs has always had a very high rate of speciation. It also has a very diverse range of habitats, from the deepest regions of the ocean to large regions of shallow seas which can afford coral reefs. The most diverse regions identified by the Census of Marine Life are around Australian and Japanese waters, which contain more than 30,000 species each, and are among the most biologically diverse in the world. Next in line are the oceans of China, the Mediterranean Sea, and the Gulf of Mexico. Besides algae and the seabirds and mammals that travel around the sea, viperfish has been regarded as the most cosmopolitan marine creature by the Census of Marine Life. Its presence was recorded in around a quarter of the world's seas. And for every marine species of all kinds known to science, scientists of the Census of Marine Life estimate that at least 4 have yet to be discovered. For example, about 70% of species of fish have been discovered, but for most other groups, likely less than 1/3 are known. Our research team has found the number of marine fish species was about 16,764 and was growing at around 100 a year. So scientists estimate that there are almost 22,000 fish species in the world's oceans. The most fruitful potential areas for discovery include the tropics, deep seas, and southern hemisphere, although most ocean organisms still remain nameless, and their numbers unknown at the end of the Census of Marine Life. We still gained an important and exciting start.
Definitely. That's a great achievement.
Thank you very much.
Okay, thanks to Alok for giving the amazing information about marine life.
All over the world, there are passionate arguments going on about how educational systems can be improved. And of all the ideas for improving education, few are as simple or attractive as reducing the number of pupils per teacher. It seems like common sense, but do these ideas have any theoretical basis? Today, I want to look at the situation in the USA and at some of the research that has been done here in America on the effects of reducing class sizes. In the last couple of decades or so, there has been considerable concern in the United States over educational standards here, following revelations that the country's secondary school students perform poorly relative to many Asian and European students. In addition, statistics have shown that students in the nation's lower income schools in the urban areas have achievement levels far below those of middle-class and upper-middle-class schools. So would reducing class sizes solve these problems? Well, we have to remember that it does have one obvious drawback. It's expensive. It requires more teachers and possibly more classrooms, equipment, and so on. On the other hand, if smaller classes really do work, the eventual economic benefits could be huge. Better education would mean that workers did their jobs more efficiently, saving the country millions of dollars. It would also mean that people were better informed about their health, bringing savings in things like medical costs and days off sick. So what reliable information do we have about the effects of reducing class sizes? There's plenty of anecdotal evidence about the effect on students' behavior, but what reliable evidence do we have for this? Let's have a look at 3 research projects that have been carried out in the USA in the last couple of decades or so. The first study I'm going to look at took place in the state of Tennessee in the late 1980s. It involved some 70 schools. In its first year, about 6,400 students were involved, and by the end of the study, 4 years later, the total number involved had grown to 12,000. What happened was that students entering kindergarten were randomly assigned to either small classes of 13 to 17 students or regular-sized classes of 22 to 26. The students remained in whatever category they had been assigned to through the 3rd grade, and then, after that, they joined a regular classroom. After the study ended in 1989, researchers conducted dozens of analyses of the data. Researchers agree that there was significant benefit for students in attending smaller classes, and it also appears that the beneficial effect was stronger for minority students. However, there's no agreement on the implications of this. We still don't know the answer to questions like how long students have to be in smaller classes to get a benefit, and how big that benefit is, for example. The second project was much larger and took place in California. Like the Tennessee study, it focused on students from kindergarten through to grade 3, but in this case, all schools throughout the state were involved. The experiment is still continuing, but results have been very inconclusive, with very little improvement noted. And the project has in fact also had several negative aspects. it meant an increased demand for teachers in almost all California districts. So the better-paying districts got a lot of the best teachers, including a fair number that moved over from the poorer districts. And there were a lot of other problems with the project. For example, there weren't any effective procedures for evaluation. All in all, this project stands as a model of what not to do in a major research project. A third initiative took place in the state of Wisconsin at around the same time as the California project began, and it's interesting to compare the two. The Wisconsin project was small. Class sizes were reduced in just 14 schools, but it was noteworthy because it targeted schools at which a significant proportion of the students were from poor families, compared with California's one-size-fits-all approach. Analysts have found that the results are very similar to the Tennessee project, with students making gains that are statistically significant and that are considerably larger than those calculated for the California initiative.
Why are we studying this? That's a question that, as a high school maths teacher, I was asked 1,000 times, and one that you, as trainee maths teachers, will certainly be asked in the future. What is it that makes maths seem so difficult and unapproachable for many students? Getting good at maths is less a matter of brain power than staying power. The difficulty lies in the amount of patience maths requires. And it needs persistence too. It's not a subject that comes automatically or intuitively to many students. Another question I used to be asked was, how am I going to use this in my life? And this is the crux of the matter. Unless students can really get to grips with the relevance of maths to their everyday lives, it makes teaching the subject a very tough task indeed, especially when they know that in this world of instant gratification, they can find answers to virtually any problem by doing a quick internet search. So what can we, as teachers, do to make maths more accessible and interesting to our students? Well, for a start, we need to help them see how maths is needed in their daily interactions. Whether it's following a recipe or deciding how much paint you need for your kitchen walls, we need to help students see that it's maths that's at work in achieving these goals. It's easy to see why simply forcing students to employ methods of memorization or reciting formulas leads to a teacher's failure to inspire in the maths classroom. Maths is a universal language. Anywhere you go, you can interact with people in all walks of life, and they'll understand you if you speak maths. The language of numbers can help anyone perform daily tasks and make essential decisions. For thousands of years, the same principles of maths have been practiced by mankind around the globe. In order to get things done, especially in modern society, you simply have to employ maths. Your proficiency in the subject, or even a little knowledge of the fundamental operations of it, can help you shop wisely and stay within a budget, or get your head round population growth. Maths is also critical to a range of professions, and whatever your background, if you've been taught the basic operations of maths, you have the potential to become a millionaire. Just as literacy helps us get ahead in life, so does counting, and the ability to make informed financial decisions. And it doesn't stop at work or daily transactions. Less obvious benefits of studying maths include other real-life applications, such as the ability to learn to play a musical instrument, become a dancer, or sail a boat. So what is it that we need to be teaching? Yes, it's difficult to see how some mathematical concepts translate to the world outside education. Perhaps you'll never use a particular formula in your job, but by learning the process, you'll have trained your brain to solve problems whilst reinforcing the basics of maths. There are, however, formulas which are more transparently useful. Things like an ability to properly assess risk or statistics. Things which even students should be able to see will equip them for the world beyond education. Maths makes our minds flexible enough to find solutions to complex, real-world problems. Maths is a cumulative discipline. You have to gain an understanding in one area before you can effectively go on to acquire another. From the basic foundation of addition and multiplication to the complexities of quadratic equations, the only way to build a framework of knowledge is to learn step by step. So, how did I answer that question? What is the point of doing this? Until I got my students thinking about how they use maths to download music from the internet and hand over their cash for popcorn at the cinema, nothing I said made any difference. So I asked them to imagine a life with no maths. That would mean no means of marking time with calendars or watches, no money or concepts like measurement. The idea of missing birthdays, not being able to top up their mobile phones, and a halt to the development of computer games made them open their eyes to the reality of life without maths. What better way to demonstrate the purpose of maths than to relate it to their own existence? Moving on now to another aspect.